Alright, so this next one here is where the vertex of the angle is not necessarily the center, but it's inside of the circle. Um, Here's what we're going to do for that one. We're going to use the formula that ties to that. This will be that top right one right there. This basically says add your two arcs and then divide by 2. Basically, that's an average right there. So we're going to go ahead and try that here on this here. So you just average your two arcs, 40 plus 30. And then divide that by 2, whatever that is. And what is that, 70? And 1/2 of 70 should be the 35 degrees right there. And that means this angle right here, x, is 35. And then this vertical angle is also 35. And notice how those are not the same measures as these arcs right here. That's because it's not a central angle there. So that's all you're going to need to do there on that one. 25 kind of uses the same idea. This one's a little special because they give you a right angle here in the middle. So we actually know that the final answer equals 90. So what I'm going to do here is write 1/2 and then x plus 100 like that. So basically we're working backwards here on this one. So a couple ways you can get rid of the 1/2. I like to multiply it by 2 right there, and that would cancel out. And you wouldn't have to distribute a fraction if you can cancel out your fraction. So that'll get us 180 over here, and then equals x plus 100. And then we can subtract, and we can get x is 80 degrees. And then that'll be it right there. And then if you want to go and test it out, you can do 80 plus 100, divide that by 2. That should get you back to the 90 here in the middle. So that's kind of a little bit of a special one right there, but using that same idea. Okay, now 26, there's really not anything on the formula chart that helps us with 26, but it does use the fact that you have, it looks like a piece of a radius that's perpendicular right there. If it's perpendicular, it must be a perpendicular bisector, which means both of these here will be 5. So it'll cut that entire chord in half. And then I'm going to redraw the radius like this here, x. And if you redraw it like that, then you can say, all right, I have 3 squared plus 5 squared equals x squared. And then you use the Pythagorean theorem, solve for x. This one we might need simplest radical form. Let's see here. That would be 34 is x squared, and then we would square root 34. Now with this specific example, you can't, you can break down 34 a little bit. I think you can go like 2 and, what is that? Maybe 17, but then 17 you couldn't break down, so you would just leave your answer like that. Or if they ask for, rounding or approximate answer, you would do a decimal. But square root of 34 is the best thing to write there on that one.